So this is a cuboid, a rectangular parallelepiped or cuboid, and we will draw a diagonal from this vertex to the opposite vertex from here to here. Okay, we can do it from this vertex to this vertex also, or from this vertex to this vertex also. So we choose to draw from here to here. Okay, this is a vertex from, this is a diagonal from one vertex to the other opposite vertex inside the parallelepiped or cuboid. Now we have to find the length of this vertex, of this diagonal. Okay, length of this diagonal from this vertex to this vertex. We have to find the length. So for that, first we will take this surface, this whole surface. It looks like this. This surface, okay, this looks like this, but actually it is a side view. It is a side view only, this surface, but actually it looks like this, rectangular, right? Because this is a cuboid, so we are viewing it from the side, so we are getting this view, but actually it looks like this from the top. If you view from the top, then this is the view. Okay, a rectangular shape. So if this is the rectangular shape, so what we can do is we can draw a diagonal from this point to this point. Then this becomes a right angle triangle, this whole thing. Okay, then this side becomes base, we can take it as base. This can be taken as perpendicular, and this one as hypotenuse. So base, perpendicular and hypotenuse. It is a right angle triangle. Then if we know base and perpendicular, we can find the hypotenuse by Pythagoras Theorem. So if this is B, this is P, and this is HP, hypotenuse, then hypotenuse square is equal to base square plus perpendicular square, right? Base, perpendicular, hypotenuse. So hypotenuse square is base square plus perpendicular square. So hypotenuse is equal to root over b square plus p square, right? If HP square, hypotenuse square is b square plus p square, then hypotenuse is square root of b square plus p square, right? So if we know this length and this length, we can find this length. Okay, so in this case, this base, this is denoted by L. This length, this is denoted by, say, B, length, breadth. Then this length, this one can be represented as L square plus B square. Okay, length square plus breadth square is the diagonal square. Length square plus breadth square is diagonal square, or diagonal is, if we say this is the diagonal, then diagonal is square root of L square plus b square. By the way, let me make some corrections, otherwise you may get confused a bit. Just a moment. Let us say writing b is again not appropriate. I will say in place of hp square, I will say hp square is base square, then I will write the full name, perpendicular and base, so that you don't get confused with b and b here again. So these are just labels, okay? So basically the thing is that hypotenuse square, this length is equal to this length square plus this length square. So this length is base and this length is perpendicular. So base square plus perpendicular square is equal to hypotenuse square. So hypotenuse is again base square plus perpendicular square. Okay, so if we say that this length is L and this length is B, then this length is represented by L square plus B square, square root of L square plus B square. So this is the measure of this diagonal from this point to this point. So if we draw a diagonal like this, so this represents this diagonal. So we know it is L square B square. So if this length is, this measurement is L, denoted by L length, and this is denoted by B breadth, then this length is denoted by L square plus B square. L square plus B square root over L square plus B square root over L square plus B square. Okay, same thing. This is the plane, this is the plane, this is the surface, this is the surface, this is the same surface. Okay, viewed from the top. So this diagonal is equal to L square. If this is L, then it is, and if this is B, then this length is denoted by L square plus B square root over L square plus B square. Okay, so we got the measurement of this diagonal. This is the face diagonal of this face, the face at the bottom, this whole thing, this one, this is the face, and we got the length of the diagonal, square root of L square plus B square. Now taking this base like this, and this one is, suppose this is the height of this cuboid, then it can be represented like this. This is L square plus B square, and this is H, and this diagonal from this point to this point, it is this line. Okay, look at it carefully. This is the height. Okay, this height, same thing here also we get the height. This is the height, and this diagonal at the base from here to here, from here to here. Okay, this is square root of L square plus B square, because this is L and this is B, so we get this value as L square plus B square. So value of this side is square root of L square plus B square. Then we have to find the value of this diagonal, measurement of this diagonal from here to here. So actually this represents a right angle triangle, though it does not look like a right angle triangle, but it is actually a right angle triangle. This is the baseline, it is the same line here, this is the height line, this is the height, and this diagonal is this diagonal. Okay, again in this diagram, we can see that this is a right angle triangle. Okay, so we can again apply Pythagoras theorem here. So how we can apply Pythagoras theorem? We know that this line, this diagonal, suppose we represent it by D, diagonal. This is square is equal to h square, which is the height, this line, plus L square plus B square whole square. Right? This diagonal square is equal to h square plus L plus B root over whole square. Okay? This line is L square plus B square whole square, and this line is h square. So d square is equal to h square plus root over L square plus B square whole square. This is Pythagoras theorem. Okay, this diagonal is equal to sum of squares of this line plus this line. Square of this line is square, h square, and square of this line is L square plus B square whole, root over whole square. Okay, so this is equal to h square L square plus B square. Okay, this value is equal to L square plus B square, or simply h square plus L square plus B square. So what is the value of D in the diagonal? It will be equal to root over h square plus L square plus B square. So we get the value of this diagonal from one point vertex to the opposite vertex as height square plus length square plus breadth square, then take square root of summation of all the three. So square root of h square plus L square plus B square gives us the diagonal of the cuboid. Okay, any diagonal from one vertex to the opposite vertex. Fine. Okay, so let me erase this. Now let us take the special case of a cuboid. Special case of a cube. You know, in a cube, all the three sides are equal in length. Okay, so that is a cube. Special case of a cuboid, that is a cube. So if that is the case, that means L length is equal to breadth is equal to height in case of a cube. So if this formula gives us the measurement of the diagonal from one vertex to the opposite vertex, then what will be the diagonal in case of a cube from one vertex to the opposite vertex? Suppose this is equal to a, any value, then it will be equal to d is equal to h square plus L square plus B square. So d is equal to a square plus a square plus a square, which is equal to root over 3a square, which is equal to a root 3. So this gives us the value of the diagonal from one vertex to the opposite vertex. Any diagonal from one vertex to the opposite vertex inside a cube is the length of one of its sides into square root of 3. So that gives us the length of the diagonal. And this is the formula for finding the length of the diagonal from one vertex to the opposite vertex inside a cuboid. Okay, h square plus l square plus b square root over h square plus l square plus b square, where h is height, l is length, and b is breadth. Okay, and can you tell me how do we find the what is the maximum length of a straight line that can be drawn inside a cuboid shape or a rectangular parallelepiped? What is the maximum length of a straight line? Obviously, the maximum length can be obtained by measuring the distance from two farthest points inside the rectangular parallelepiped. Okay, we find any two farthest points inside a rectangular parallelepiped. Suppose this room. So that vertex opposite to this vertex, that gives us 2 points which are farthest away from each other, right? So that gives us the maximum length of the line, that can be drawn from the longest line that can be drawn from one point inside the vertex to another point. So a diagonal like this that represents the maximum length that can be fitted inside a rectangular parallelepiped, or if it is a room, if it is a cuboid shaped room, because rooms are usually cuboid shaped, then that gives us the length of the maximum length of the rod that can be fitted inside the room. Okay, a diagonal represents from one vertex to the opposite vertex inside a cuboid, that represents the maximum length of the line that can be drawn from one point to another inside a cube. Okay, so remember this. And how to find the diagonal? By using this formula, h square root over h square plus l square plus b square, where h, l and b are height square, h and l and b are height, length and breadth respectively. Okay, and in case of a cube, because l, b and h all three are equal, so we have the formula as a into square root of 3, where a is the length of any length or breadth or height of the cube, because a cube is a special cuboid, a special case of a cuboid. Okay, and also remember this, that the body diagonal, this is a body diagonal from one vertex to the opposite vertex, that represents the maximum length of a line that can be drawn inside a cube, or the maximum length of a rod that can be fitted inside a cuboid shaped room. Okay.